Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to explain sequences. Actually, we have many types of sequences. We have linear sequence, quadratic, cubic sequence, geometric sequence, and other sequences. We have many types of sequences, but these are the main ones. What I'm going to do first, I'm going to explain the difference between each of them. How I would know if this sequence is linear or quadratic or cubic or geometric. That's the first part. Identify the type of the sequence. And in the second part, I will find the nth term. I'll find the nth term. How we find the nth term of each of them. Let's go. First, linear sequence. Linear sequence, how I figure out the linear sequence? When we have the first difference is common. The first difference is common. For example, 3, 7, 11, 15. Okay, let's see what is the first difference. From 3 to 7 we add 4. From 7 to 11 we add also 4. From 11 to 15 we add 4. We add 4. We add 4. So first difference is common. Common means the same. First difference is the same, is a constant. Every time from one term to the other term we add 4. So 4 here is a constant, and that's the first difference. So that's a linear sequence. Okay, let's quickly now to go to quadratic sequence, but let's just resize here so we can have some space. Okay, here we are. Quadratic sequence. Okay, quadratic sequence is when you have the second difference is constant, not the first one. For example, and let's take very simple sequences to understand the idea, and then later we take harder ones. So we have 1, we have 4, we have 9, we have 16, we have 25. And let's get the difference every time. From 1 to 4 we need to add 3. From 4 to 9 we need to add 5. From 9 to 16 we need to add 7. From 16 to 25 we need to add 9. Look now, do we have a constant difference? Like here we have 4, 4, 4, 4. No, we have different differences. The first difference is not constant. So that's the first difference. So let's check the second difference. From 3 to 5 we add 2. From 5 to 7 we add 2. From 7 to 9 we add 2. So that's what I mean by second difference is constant. 2 here, it comes after subtracting 2 times. So second difference. So if the second difference is common, is the same, is a constant, that's going to be quadratic sequence. And here we are. Let's say again, resize, have some space. Have some space, please. Yes. Okay, let's go to that cubic sequence. Okay. Yes. Okay, cubic sequence. I'm sure now that everyone can guess what. how we figure it out. So linear is first difference is common. Quadratic, second difference is common. Cubic, yeah, I hear you. I can hear you guys. It's third difference is common. You are correct. Let's give example now. So I'll give a simple one. Okay, 8, 27, 64, and 125. Let's see first difference, second difference, and so on. First difference, plus 7. Second difference, plus 19. Third difference. Someone would say, teacher, how you figure out the differences? Actually, what I do is I subtract second minus the first. 8 minus 1. 27 minus 8. Fourth term minus third term. Fifth term minus fourth term. And if it's the second paper, paper 4, sorry, if it's paper 4, not paper 2, so you can use the calculator as well. You can get the calculator now. I show you. Here we are. Yes, please, hurry up. Come on. Okay. So, back again to where? Yeah. So now, if I want to check now, from 27 to 64, which is 37, I can do this. 64 minus 27. Okay? But as you know now, it's really crucial to know how to add, subtract, multiply, divide. Add fractions, subtract fraction, divide them, multiply them. Whole numbers, decimals. All these must be basics for you now. Basics. Because, as you know, you all know now that paper 2 is going to be with no calculator. That's for Cambridge, IGCSE. Yes, check Edexcel still is allowed to use calculator in both papers. But so 125 minus 64, that's going to be 61. So it is 37. Oh, whoa. 37, and here is 61, and that's the first difference. Second difference, I want to get the second difference now. From 7 to 19 is plus 12. From 19 to 37, that's going to be, okay, we can do it. 37 minus 19 is 18, and 61 minus 37 is going to be 24. And as you see, guys, look now, here we are. The third difference is 6 plus 6. So that is a cubic sequence. Why? First difference is not the same. Second difference is not the same. But third difference, so third difference, sorry for my bad handwriting. Third difference is common. That's a cubic sequence. Let's go now to the geometric sequence. But let's resize this. Do resize, please. Yes. Okay, that's good. We can put a line here just to keep, yes. Amazing. Geometric sequence, or some teachers also in books they call it exponential sequence, and we call it also because for a reason. So exponential sequence from exponent. Okay, how find out that is a geometric sequence, exponential sequence? Let's see. Okay, for example, I have this sequence 100, 50, 25, 12.5. Okay, so what happens is if you check the differences, if you check from 50, it's minus 50 minus 25 minus 12.5. What do you see, guys? What do you see? You'll find out that you actually are getting the same values again. Look, 50, 50, 25, 25, 12.5, 12.5. It's actually the same again. I'm getting the same sequence, the repeated numbers again. That's geometric sequence. That's exponential sequence. Or, and what I like to use, someone said to you, but he did not check. He did not check the second difference, the third difference. Okay, go ahead. If you want to check. So from minus 50 to minus 25, I added actually 25. From 25 to 12, I added 12.5. So again, you see, repeated again. If I keep going, I'm not gonna find any common difference. So I have to know that this is exponential or geometric sequence. And what I always get shocked, many students, they don't know that. They don't know about the geometric sequence. So as you see, there is no common difference. There is no common difference. But there is what? There is common ratio. Look, half times 100. So this 100 is multiplied by half. You get 50. Multiply by half, you get 25. Multiply by half, you get 12.5. You get 12.5. So that's called common ratio. So how I know if it is geometric exponential sequence, you'll find a common ratio. Someone teach, what do you mean by ratio? Again, you multiply each term by a certain number to get the next term. So half, 100 multiplied by half, then 50 multiplied by half, then 25 multiplied by half. It's multiplication. It's not addition or subtraction. It's not common difference. It's common ratio. Then how I find it? How I find the nth term? That's what I'll take later, okay? That's first part. What about others? Others could be many. Or I'll relate to the examples, okay? So now, quickly now, let's explain each how to find the nth term now. The second part, the part that most of you are waiting for. How we find the nth term. How to find the nth term. Let's start with the linear one, because that's the easiest. So here we use this, okay. Nth term, you have to know that linear sequence is in this form. A n plus b. So here n is raised to the power of 1. It's a n power 1 plus b. B is a constant. How we find a, if you know how to find a and how to find b, so you got the sequence. So you got the nth term. If you know how to get a and to get b. So a, simply a is the first common difference. A is the first common difference. Oh, let's write it with proper and pen. So a here, how we get it, is going to be the first common difference. We said that the first difference is going to be common. That's first common difference is going to be a first common difference. Okay, can we do this for this example, teacher? Yes, for sure. So as you see here, guys, I'm asking you now, what is the common difference? What is the common difference? It's 4. So it's going to be 4n. Okay, what about b? B is the adjustment. What do you mean by adjustment? I will put n equal 1. I know that the first term is how much? You know, that's the first term, that's second term, third term, fourth term. If someone I don't know where I'm writing here, guys. I'm here in the linear sequence here. So the first term is 1. That's second term, third term, fourth term. So the first term is 7. Second term is, first term is 3. Second term is 7. Third term is 11. Fourth term is 15. So I know that the first term, when n equals 1, the term has to be 3. So when n equals 1, the term has to be 3. But if I put n here equal 1, it's going to be 4 times 1 equal 4. It's not going to be 3. So I need to adjust now. It's not exact for n. It's for n minus 1. If someone did not get it. So whatever I get here, I'll make it. I need 4n. I know 4n plus b has to be equal 3 if n equals 1. When n equals 1. So let's do it now. So 4 times 1, 4 plus b equals 3. Then subtract 4, you'll get b equal negative 1. So what is the nth term? The nth term is, it's just size this again. Oh, my bad. Okay. Sorry, there's some mess here, there. Okay. So I know now that b equals negative 1. So it will be 4n minus 1. That's the nth term. 4n minus 1. So again, a is first common difference. So it's which is 4. And b is adjustment. How adjustment? I know that the nth term should have 4n. But if you put n equal 1, it will be equals 4, not 3. If you put n equals 2, it should be 7, not 8, because 4 times 2 is 8. If you put n equals 3, it will be 12, not 11. So that means I need to subtract 1 every time. That's the nth term. Okay? Quadratic, because it needs space, I'll do it right here now. So quadratic, quickly now, quadratic is a n squared plus bn plus c. an squared plus bn plus c. We have 2 ways to do it, actually. 2 ways. I know that there is a certain way is used in our schools. So I'll start with this way. And then maybe at the end, if there is time, we can show the other way, which many students, they find it very easy as well. So I know that my equation could be in this form, an squared plus bn plus c. So I need to get how much is a, how much is b, how much is c. If I find them, that's going to be my nth term. You have to know that not every time we'll have the 3 terms. Not every time I'll have n squared plus bn plus c. No, sometimes we have only the first term and the last term. So maybe I have only an squared plus c. Maybe I have an squared plus bn only. Maybe I have the 3 term, which is an squared plus bn plus c. So not every time I have all of them. Which one will be the easiest? The easiest is this, is to have only the constant and the n squared. But as you see, I cannot have only bn plus c. No way. It's not going to be quadratic. Quadratic means we have power of 2. So maybe I have an squared and the constant, just a number. For example, 2n squared plus 5. Only this. Or I could have an squared and bn. So it could be, for example, n squared plus 3n, and no constant. And maybe I have all of them. I have 3n squared plus 2n plus 7. So I have all the 3 terms. So I could have 2 terms, I could have 3 terms. Also it could be, sorry I forgot to say that, it could be only an squared. Maybe I don't have the constant, I don't have the nth one, which is bn. Maybe I have only an squared. So all these are possible. Let's see our example, how it's going to be. So I'm going to teach you the first way that is used by many teachers, especially in our school, which is I get to check. Not for sure, in the exam it's not going to tell you it's quadratic. In the exam, don't expect that's going to tell you it's quadratic here. No way. You have to figure out. How I figure out? Check. Common difference, bro. Common difference. So, from -3 to 3 is how much? Is plus 6. Plus 6. From 3 to 13 is plus 10. From 13 to 27 is plus 14. From 27 is going to be plus 18. First difference is not the same. It's not linear. It's not linear. Okay. So let's check the second difference. Plus 4. Plus 4. Plus 4. Plus 4. We are lucky. Second difference. Second is common. So that's quadratic. خلاص. It's a quadratic. طيب, I know that the quadratic an squared plus bn plus c. Okay, how we find a? So every time you want to find a, the coefficient of n squared, a is equal second common difference, second common difference divided by 2. Second common difference divided by 2. What the second common difference here? It's 4. Divided by 2 is going to be 2. So I know now that my nth term will be 2n squared. 2n squared. Okay, we still need to find bn and c. I still need to find bn and c. How we find it? The way that we use, or some teachers they use in our school, and this is why I started with, is to get the sequence of 2n squared. Get the sequence. How? Put n equal 1. Put n equal 1. N equal 1. N equal 2. N equal 3. N equal 4. N equal 5. And get the nth term when it's only 2n squared. So 2 times 1 squared, it will be 2. 2 times 2 squared, you know what I'm doing, guys? I'm putting n equal 1. Then I see what's going to be the answer. N equal 2. 2 squared is 4. 4 times 2 is 8. And then I put n equal 3. 3 squared is 9 times 2 is 18, and so on. So 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32, and so on. 5 squared is 25 times 2 is 50. And then now, that's the sequence of 2n squared. And that's my original sequence. I do now subtraction. Okay, I do subtraction now. Let's choose another color. So, the original sequence is -3, not 2. It's 3. It's 13. It's 27. It's 45. Do subtraction. And see how much you will get. Will you get a constant? If you get a constant, that means you got C only. And there is no Bn. Or you will get different, that means you will have Bn. So if you got 3, 3, 3, 3, 3, 3, so that means we have only an squared plus C. If you have 3, 7, 11, 15, 19, so that means not the same. So you have Bn, and maybe you have Bn plus C. Okay? So let's see the difference now. The difference, negative 3 minus 2, negative 3 minus 2 is going to be negative 5. 3 minus 8 is going to be negative 5. 13 minus 18 is negative 5. 27 minus 32 is negative 5. 45 minus 50 is negative 5. Wow! I got a constant. I got C. That means there is no Bn. There is no Bn. B is 0. It's only C. So now I know that the difference between 2n squared and my original sequence is only just to subtract 5. So that's what I'm going to do. So the n star is going to be 2n squared minus 5. Let's check. Let's check. 2n squared minus 5. Put n equal 1. 1 squared is 1 times 2 is 2 minus 5 is going to be negative 3. Someone is not. 1 squared times 2 minus 5, that's going to give me negative 3. Yes, here it is, negative 3. Put n equals 2. Put n equals 2. So it's going to be 2 squared times 2 minus 5. 2 squared is 4 times 2 is 8 minus 5 is 3. Correct. Put n equal 3. 3 squared is 9 times 2 is 18 minus 5 is going to be 13. Yes, that's the nth term. The nth term. Okay, we have, okay, that's example if only we have n squared plus c. And that's another example now. Here we have example if it's an squared plus bn plus c. Not every time it's going to be constant. Yalla, let's quickly do this. I know it's too much time, but a really important lesson. Okay, so here first difference is minus 2, minus 4, minus, oh wait, not minus 4 is not written properly. Minus 4, and here minus 6. So second difference from negative 2 to negative 4, that's going to be minus 6. Oh, what's minus 6? Minus 2 only. From negative 4 to minus 6 is negative 2. Don't forget, whenever you feel confused, use the calculator. Where is the calculator? Where did it go? Use the calculator if you are not sure. If it's paper 4. Here we are. How I use the calculator? Just to do second minus the first. So I was confused about the second one. So negative 4 minus negative 2. Look, it's negative 2. Negative 6 minus negative 4 is negative 2. Okay? How? Okay, so that means second difference is common. So now I get the A. Don't forget, it's a n squared plus bn plus c. If I found A and B and C, that's it. So and now I said to get A is equal second common difference divided by 2. It's a negative 2. Divided by 2 is going to be negative 1. So it's a negative 1. So A is negative 1. So I know now that it's going to be negative 1n squared. As you know, if it's 1, I can ignore it. So I just say negative n squared. And then get the sequence of negative n squared. Get the sequence. Get the sequence. If it's n is 1, it will be negative 1. If n is 2, it's going to be negative 4. If n is 3, it's going to be negative 9. If n is 4, it's going to be negative 16, negative 25. Okay, but my original sequence is not that. My original sequence is 7, 5, 1, negative 5. So subtract. To see, will you get a common difference or not? So 7 minus negative 1 minus negative 7 minus negative 1. That's going to be 8. 5 minus negative 4. That's 9. 1 minus, it's going to be 10. That's going to be negative 5 minus, it's going to be 11. And this is going to be 12 for sure without even doing it. Oh, my bad. I did not get a common difference. So that means you will have Bn. That means there is Bn. How I'll find Bn? It's a linear sequence, guys. It's a linear sequence. Look, every time I add 1, I add 1, I add 1, I add 1. So it's, this is linear sequence. This is going to be Bn plus C. So I know now, if every time I add 1, so it will be 1n. It will be 1n. So 1n. Is it 1n exactly? No. Because look, if n is 1, if n equal 1, is going to be 1, not 8. If n is 2, it's going to be 2, not 9. That means every time I have to add 7. So that's the adjustment now. So what is my sequence now? Is going to be negative n squared plus n plus 7. Negative n squared plus n plus 7. And let's check. Let's put n equal 1. It will be negative 1 squared plus 1 plus 7. So it will be 1 squared is 1. So it will be 1. The negative is outside. It will be negative 1 plus 1 plus 7. 1 and negative 1 cancel each other. It's going to be 7. So I'm correct. So that's my sequence. Okay, teacher, that's the way that we use in the school for quadratic. There is another way. Maybe some of you will find easier. I'll use it here, which is, as you know, it's the second common difference. The second common difference. So as you know, we have first common difference. First common difference. And we have second common difference. Okay, so let's see, for example here, 6 plus 12. And then, okay, from here to here is how much? From 6 to 12 is 6 plus 6. And here plus 8. And then from here to here is plus 2. He already told me that this is quadratic. Okay, if it's not quadratic, if he wants me to find out the sequence, he should give me one more term at least. So plus 2. So now, what is the other way? The other way is I'm going to give you everything. So second common 2a is equal to second common difference. That is going to be equal to a. And 3a plus b is going to be equal to the first difference. And a plus b plus c is equal the first term. For sure you don't understand anything now. I have 3 equations. 2a is equal the second common difference. 3a plus b is equal the first difference, and a plus b plus c equal the first term. Let's see here. So I told you the common difference is going to be 2. That's second. It has to be equal to a. So 2a equals 2. So divide by 2. So a equals 1. I got how much is a. That's first thing. So that's first one. Second one, 3a plus b is going to be equal the first difference. Which, teacher, is not common? Yeah, I know it's not common. I'm going to take only the first difference. The first difference is 6. So 3a plus b is equal 6. So I know how much is a already. It's a 1. So 3 times 1, 3 plus b equals 6. Then minus 3. So I know b is going to be equal 3. And a plus b plus c is going to be the first term. What the first term is going to be 6. So again, so that's a plus b plus c. The first difference is 3a plus b. And this one is the second common difference is going to be 2a. You have 3 equations. And from each equation, you get one of the variables. From each equation, from one equation you get a, from one equation you get b, from the third equation you'll get c, then you'll have the equation. So a plus b plus c equals 6. A plus b plus c equals 6. I know how much is a. A is 1. I know how much is b. B is 3. I don't know how much is c, but I can find it. So it will be 4 plus c equals 6. So c equals 2. So I have a equal 1. I have b equal 3. I have c equal 2. And you know my equation is a n squared plus b n plus c. So I can put the variables now. A is going to be 1. So 1n squared. I can just write n squared. bn, so it's 3n plus c plus 2. And that's my nth term. Actually, it's very easy way. It's easier than the other one. The other one has some confusion. This is very easy way for quadratic sequence. And the video became 37. That's too much. I think I'll carry on in another video about the cubic sequence and geometric sequence and the others. Hope this is really beneficial, guys. Oh, don't forget to check. You can check. Put n equal 1. So it will be 1 squared 1 plus 3 times 1 is 3 plus 2 is going to be 6. Put a is 2. Put n is 2. 4 plus 6 plus 2 is going to be 12. So my sequence is right. I'll see you in the second video, inshallah.